This is going to be lesson 25-3, and we are still studying angles that are formed in circles. And this time, the angles are going to be formed by just a couple of chords. There's not going to be anything special about their vertex. I am scrolling down and going to problem number 5. That's where we are going to start our lesson. So problem number 5 asks us to draw AP. So I am going to draw in AP. Then it wants us to know about each of the angles located at X. Okay, now these are the angles that we are learning about. These are what we call, well, they don't really have a name. The angles that we've learned in the past were called central angles. And you guys remember central angles have their vertex where? The vertex is at the center. And then we did inscribed angles. And the inscribed angles had their vertex where? Vertex on the circle. Okay, and these are, they don't have a name. They're just formed by chords, but they're located on the interior. So I do call them inside. And this is not an official name. This is an official name. This is an official vocabulary word. This is not. This is what I call them. These are inside angles, okay? And they are formed by chords. Formed by chords. Okay, and so since those are formed by chords, they don't have a formula quite as neat as these two, but there is a relationship between the arcs that are intercepted by these angles. Okay, so that's what we are in the process of discovering. So notice that we're talking about both of these angles X. Why? Because one, they're vertical angles. So you know that they're going to have the same measure. So you can find either one of these measures. If you find this measure, you'll know that one. But each one of these angles have an intercepted arc, and these arcs don't look like they're the same size, even though they're chords. I mean, even though their angles are, which is true. The arcs are not going to be not necessarily the same size, but the angles will be, and you'll see a relationship. We're going to go through this little exercise. So they've asked us to draw AP. We did. Now it says each of these angles X is an exterior angle for triangle ALP. So if you see triangle ALP, this one right here, I'm going to just kind of sketch it out here. Here's ALP. Okay, there's ALP. I'm not crazy about this marker, so I'm going to try a different one. Okay, and then we extend this side. We extend it out. Then there's where we find angle X. So what do we know about the measure of that angle? It's an exterior angle. This is the adjacent interior angle of the triangle. So that means that this angle 1 and this, we're going to call it angle 2. I'll put them in here, angle 1 and angle 2. Angle 1 and angle 2 are the remote interior angles. So that means if we add angle 1 and angle 2 up, we'll get the measure of angle X. And then if you look at the other, I'm going to draw again APL. Okay, I'm again drawing APL, and this time I'm extending this one. So here's the angle X. This is the attached or adjacent interior angle. So angle 1 and angle 2 are what we call the remote interior angles. So we know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle X. So I'm going to say that right here. Now you can only put angle 1 and angle 2 if you've put a 1 and a 2 up there. Otherwise you'd have to put angle LAP and angle APL. Okay, so each of those angles, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle X. Now it says use the inscribed measure. So in other words, What's true about angle 2 over here? This angle 2 is an inscribed angle. So if I come up here and I kind of color this angle right here, this is the intercepted arc for that angle. So it's an inscribed angle, and we've already learned about inscribed angles. What did we learn? We learned that the measure of the angle is half the measure of the arc. So here it says, use the inscribed angle measure to find the measure of angle APB. So this is angle 2 right here. That's what they're talking about. Find the measure of angle 2 in terms of A and B. So the measure of angle 2 is A divided by 2. Arc A divided by 2. It's half of the arc. Well, if we go over here, and let me change the color of my highlighter. Let's do blue. And I measure this angle right here. Well, this is the arc that goes along with that angle, right? Because this is the angle right here. So this is the intercepted arc that goes with that angle. So the measure of angle 1, is equal to half of B. And that's how we say half of B. So now we're going to do a little algebra. Okay, a little algebra says, okay, let's take this sentence right here and let's rewrite it. Use your responses to part B and C to find an expression to find the measure of angle X. So we could say the measure of angle X is equal to half of A plus half of B. Now, you can certainly leave it like that, but the form that I'm most used to is this formula. The formula that says if you want to find the measure of, and remember what I called it a while ago, and remember this is just my word, you want to find the measure of either one of these inside angles. You still need their arc measures. You just need to add them together because it takes both arcs to make these total up these angles. So add them together, but then take half, okay? So, and this is an explanation of why, okay? So this is an algebraic proof for why. But the bottom line is that's the formula that you need to find the measure of the angles, okay? So let's go back over here. Let me blow this up a little bit so it's a little bit bigger. And we'll fill this in. It says complete the following theorem. When two chords intersect in the, and we'll say interior of a circle, then the measure of each angle formed is half the sum of the measure of the intercepted arcs by the angle and its, oh, I don't know what goes there. By the angle and its, oh, vertical angle. Okay, so yeah, it takes the two angles. So you're finding the measure of either one of them. Okay, so let me go back. And it's, the word that I was thinking didn't make any sense. I wanted to put, and it's equal. And that's because I know that in this picture down here that, you know, these are equal angles. So I'm not going to work, well, maybe I can work this problem. So recall that WAX, okay, so this angle right here is 60 degrees. And it says that the arc WX is 100. Okay, so remember that if this is 60 degrees, this is 60 degrees, okay? They're vertical angles, but either one of those 60-degree angles, the angle, remember the angle, because it was X is equal to half the arcs, okay? And if that doesn't make any sense, then you can say the angle, and you need to just know the inside angle, or, you know, whatever you want to remember, is equal to half, you can put sum of arcs. or I don't know. I mean, whatever, if you want to put, you know, the angle is equal to half arc plus arc, if that helps you. I don't know what you want to put on your study sheet or whatever, but that's any of those will work. You just need to pick something that works for you, so that you will be able to remember this. Okay, so we know that the angle, so we know that the 60 is equal to half WX, the measure of WX, and I should have put a little M right there, plus the measure of ZY, of arc ZY. So I'm writing down the angle is equal to half an arc plus another arc. And for these two angles, this is the intercepted arc and this is the intercepted arc. So we add these two arcs together and take half of it. So let me finish doing the algebra problem. The measure of WX is 100 plus, I need this other number right here, okay, to figure out what has to, well, we know that we're taking half of something and getting 60, so let's undo taking half. How do you undo taking half? You multiply both sides by 2. Okay, multiplying by 2 will make that half go away. So we get 120 is equal to 100 plus what? Subtract 100 from both sides. It just turned into an algebra problem. Instead of putting an X right there, I just put a question mark. So we've got the missing arc is equal to 20 degrees. So this right here should be 20 degrees. 100 plus 20 is 120 divided by 2 gives you 60. Okay, so recall then that means this one right here is 20 degrees. So the measure of arc WX plus arc ZY equals 120. And if WX is 100, then which arc in the figure represents the, oh, I don't know. We didn't do that part. It doesn't matter. Okay, so I'm going to go ahead and stop the video and then decide if I need to go over number 9 with you. I don't know that it's a problem that we need to do. But if I need to do it, then I'll do it on the next video. If not, then go ahead and start doing the check your understanding and the lesson practice.